Okay. So that's advent of code, and that means we have about 45 minutes to go back to waveform collapse, roguelike tutorial. It's been a while since we looked at this, so I have to warm my brain back up here. No, we're not in the middle of stuff. Looks like we have everything checked in. There's an iteration function. Did I start that? I did. So over here in the solver, let's just make sure everything is happy here. Yeah, this is just warnings because things aren't being used yet. That's not bad. So let's edit that. Yep. So this is where we added the to do. Okay. Very good. So we have a big long function, but like I said last time we looked at this, a lot of repetitive code we can probably copy paste and get done quickly. Right? It's just like this guy here, count neighbors, had a lot of repetitive code. So let's start working on iteration. If self, let's get rid of false here. Remaining is empty. Return true. Oh, okay. So I probably should look at what is this doing, right? What we're trying to do is making a map out of chunks of other maps, finding where the exits are on the border of each tile, and then we want to create a brand new map that connects up. And we choose two tiles at random and say, can they go next to each other? And so we're creating this solver function. Oh, thank you, Epic. I missed your not bad there. And I also wanted, although Lush Vino is not here, he did subscribe, or they did subscribe 20 hours ago. So thank you if you're watching this, Lush Vino on YouTube. Okay, count neighbors, counts how many neighbors are possible to be, right? For each chunk, right? We get a chunk. If the chunk X, we can see how many neighbors there are, if there's a chunk index there. And now we're going to iterate over all of them to see what can fit. This does the hard work, and it's a pretty big function. So where are we? So I'll add the comments here. Populate count of the remaining list. So we clone the remaining list. And we're going to check to see if any neighbors exist. I'm going to say for R in remain, copy iter mute. R.0. So the remaining, it's obviously a tuple, right? We have R.0. We're not using R.1 here. But we can look at what that is just real quick. Remaining is a vector of tuples, right? A U size and an I32. And that gets all set to initialize at 0. And then as we loop through this iteration, we're going to be setting it up. And I think this does one iteration at a time. Okay, Epic says, Esteban Kuber has on several occasions said that his goal is people should be able to learn Rust using Rust's diagnostic messages / error messages. Yeah, I mean, it's most of the time the error messages are useful. Sometimes the compiler will not quite put you in the right spot, especially when you have brace matching mistakes. But for the most part, I've found Rust's error messages to be very useful, or very informative. Chunks X and chunk Y divided by that. Yeah, he's pretty close. I agree, Epic. let neighbor count greater than 0. Neighbors exist is true. And then we're going to change R, keeping the index, but updating the neighbor count. All right, so now that we've looped over all the remaining things and updating their neighbor counts, we're going to sort them. B.1.compare to A.1. And then we're going to reset the struct with that information. Okay. All right. So we're going to pick a chunk we haven't dealt with yet, and then remove it from the remaining list, and then I assume we're going to start working on it. Yeah, so here's where we say if there's no neighbors, then there's and define the constraints with no neighbors, and if there are neighbors, then we have to find what constraints can be met. And then if possible options, apparently we're going to say, oh no, it's not possible. Okay, we'll get there. Hopefully this will go relatively quickly once we can start copying and pasting code. We keep doing roll dice instead of like just to get a random number. So it's I think the roll dice is not uniform, right? It's modeling an n-sided die, I thought. I'll have to look that up. Okay. So we grab it here, we remove it from the remaining list, and now we're going to say these two lines of code again, except it's going to be chunk index, right? And then let mute neighbors 0, and then let mute options. Come on. Vec, vec, use size, vec new. And then we're going to check chunk x and chunk. Okay, so if chunk x is greater than 0, what are we going to do? Left index, self chunk index, chunk x minus 1, and chunk y. And then we're going to say if let sum nt equals self chunks left index neighbors plus equals 1 and options push self constraints nt compatible with 3.clone. All right, so if we found if chunk x is greater than 0, it means there's a chunk to the left. So we're going to see, there could be a chunk to the left. So we're going to look to see if there is one. And if there is one, we're going to add it to our compatibility matrix, which is in options, which we created right here. And then we're going to do the same thing for if x is less than chunks x is less than self chunks x minus 1. So if there can be some to the right, then we'll do this exact same code, except we're going to do it to the right. And instead of 3, it's 2, right? So we can just copy these lines of code, splop them in there, and change left to right, change left to right, and change 3 to 2, right? And then we have this exact same chunk of code here, but for the y's. If we can go down, then there might be something up. Oh, we got to change this thing here. This is chunk x plus 1. This is chunk y minus 1. And this is up. And this is going to be 2. Oh, this is going to be 1, sorry. And then it chunks. This is going to be y, and then down. And this is chunk y plus 1 because we're going down. This becomes down. And this becomes 0. Right? So we went through that code pretty quickly. I'm just running cargo check, but I don't know if it's going to... Oh. Neighbor count. What did I do wrong there? If neighbor count. I put let. Not found in the scope. It's right here. Oh, neighbors exist. Huh. Wait a minute. Neighbor count is greater than 0. Neighbors exist is true. Where does neighbor count set? I see neighbors here. So this must be a bug in maybe this version of it. Let's take a quick peek at the repo. And see, we probably just need to initialize map builders. Probably just need to initialize it to 0 somewhere. And this is called iteration. Oh, there's this line. Oh, maybe I just missed that line. Where were we? Yeah, okay, I just missed that line. All right. Let's put that line in there. Run a quick cargo check. We still have an error. What's the error on this one? Oh. These all get semicolons, right? Like that. And because we have to return a true or false and we're not doing that. This says mismatched types also. Okay, so I'm just going to say for here, this is the end of this function, right? I'll just say false. Just to get it to not be annoying. There we go. Okay, so now we have 5 warnings only because we're not returning what we're expecting to return. All right, so now if neij equals 0, so we can have anything. Right, because if there's nothing that matches, then any tile can go next to it because it doesn't need to exit into this current tile. Right? So that's what we're going to do here. Self chunks, chunk index. So that's an option. And then let left x is equal to chunk x as I32 times self chunk size as I32. And can we do copy paste here? I'm going to try. So that's right. This is top, bottom, and this will be chunk y. And this is chunk y as I32 plus 1. Stop hitting F1. And we'll do that here. Plus 1. Okay. And then that's those. So let mute I usize 0, top y to bottom y, for x in top left x to right x. Map index is map dot xy index. Constraints new chunk index pattern of I. Right, so we're going to start at 0 here. Tiles map idx is equal to tile, and then we're going to increment I. So it's going to give us each one of the map chunks around this chunk. And that closes out the neighbors section. Neighbors is 0 section. Else, there are neighbors. So we try to be compatible with them. Right? We're O in options iter. Okay, we're going to iterate over all of our options. Insert them into this options to check thing, which is something I forgot to put right here. All right, so the hash set allows us to insert the same one over and over again, and it won't make duplicates. So that's kind of handy. And then we have possible options. Because it could be more than one that will match, right? New chunk index in options to check iter. Possible equals true. O in options iter. If O does not contain new chunk index, then possible is false. And this is another place where I'm going to insert. I paused because I was looking to see if the code, we don't need to keep checking the options after that, because once we set possible to false, we can just break out of it. And then say, then if it's still possible after that, then we're going to add it to our possible options. Right? Okay. So if our possible options are empty, we didn't find anything, RLTK console log. Ooh, do we have the console in here? We don't. Use RLTK console. Oh, we don't have to, right? Because I just did the whole path here. Never mind. Oh no, it's not possible. Okay, and then self possible is false and return true. All right, if it is possible, we don't need the else here, because once we return, we can't go any further. So I'm just going to indent all this to here. This is the function. Oh, this is the else boundary, right? Okay, good. Let new chunk index. We're almost done with this. Possible options. Len is 1. Then index is 0. Else. We're going to pick a random one. I guess this is to prevent us from putting in a 0 here. Makes sense, right? If there's only one, then just call that. Otherwise, we'll grab it from the random number generator. Self chunks, chunk index. As your size. And then we're going to do left, right, top, and bottom, just like we did here, right? It's the same exact code. right? And then we have this. Let's split this because then I can come back up here and grab the same exact code, right? Is there anything different about it? Constraints, new chunk index, map tile, tile. Okay, so it's just duplicate code. All right. That's probably something we can clean up later. Let's shift it over so it fits in there. Oh wait, this whole thing needs to be shifted back. Just like that. And then that's the end of this else. And then we're going to return false. Why are we returning false? If we've just gone through this, we don't return true here. Oh, we're only returning true if it's not possible? Maybe returns false if we should stop looking, and return true if we keep looking? There's a giant description here. So there's nothing left in remaining. We've completed the map. We return that we have completed the map. So what are we returning? We're returning... Oops, that's the solver impl. This is the iteration, yeah. So we're returning true, saying the map is done. We take a clone of the remaining, we iterate over the copy, and we update our remaining to see what neighbors are found. The chunk with the most neighbors is first, right? This is all, yeah, if there isn't left most chunk, right. So this is it may have a chunk to the west, so we can calculate the index of that chunk, right. So that's what we were saying as we went through this. If there are neighbors, then we do this. Oh, I should update my stream title, right? Rust language, what are we doing now? Rust Roguelike. Tutorial. Okay, I forgot to update my stream info. There we go. All right, so it's a long function. It isn't complicated. I don't know. It's pretty complex. So it's now building the map based on what neighbors can go next to what neighbors. Not the greatest map, but you can watch the solver chug along, placing tiles one at a time. And with WFC test 2, it goes even better. Okay, so this should actually now, once we can get it to check, we should be able to get it to generate a map for the roguelike. Although I do have a brace mistake somewhere. This is where Rust isn't 100% great. Let's see, line 168, it thinks we have an extra close paren. Yeah, I think that line is wrong. No, RNG roll dice. Oh, this one's wrong. Okay. Oh, did I typo that? 123. Yeah, new chunk. IDX. Oh. Top Y and bottom Y. That means I copied that same mistake down here. And then I have a typo on this one. Like that. And we don't have hash set. Use standard collections hash set. Vec new. How did I miss that? That's weird. What else? Map IDX. What else? Is empty, doesn't exist. Oh, because I spelt it wrong. EMPTY. And then we have what? Slice indices are type usize or ranges of usize. Yeah, I'm just trying to index into it though, right? Oh, it has to just say as usize. Okay, so that should have been an error up here too, right? Because we had the same exact code. Didn't complain up here. All right. 2 warnings. Let's take a look at what the warnings are. So we're not, value signs possible is never used. Oh. Self possible. And that's different to this one here. Or was it this? Let mute possible is true, the possible is false, and then break. Oh, wait a minute. I must have messed this up. For oh yeah. Okay, so this goes here. And those come in, right? Yeah, because that lines up with the okay. Okay, so now we should actually, oh, you know what I need to do, I forgot to do is restart. After rebooting, you got to restart the server. And it's looking for WASM. All right, so refresh. Okay, so this is our old code. Let's build the new code. Let's pull up the console in case something shows up on the console. I should get rid of those guys there. All right, refresh. Oh yeah, okay, so it's building up a map. It's interesting though that, you know, some of the chunks don't have exits, and so they just go next to other ones without exits, and therefore you have no exit. Okay. It does create a pretty interesting map though, based on all the chunks from the other thing. Oh, that. And then did you see when it finally finished the map, it looked for all the connected sections. But what's bothering me now is that it's actually going too far on the edge. I don't know if you saw on the edge. Let's see if I can get over there. I should just give myself a permanent spell of mag. I can't get over there from here. Maybe I can get down this way. Yeah. Oh, it did. Okay. When it was showing the map, it didn't have the edges on there. But now it does. Okay. So now I'm no longer worried. All right. So actually, that was that whole chunk. So, oops. Yeah. Okay, good. I went too fast with my return key there. I was worried I committed something I shouldn't have committed. Okay, so we basically, in this one, we added the hash set because we needed to add it for this thing, and this is a giant wodge of code. So this is the iteration function. Added iteration function for waveform collapse map. And then they said check it out. It runs like this, yeah, and then we can use WFC test. What file is that in? RG. There. Really? How about just WFC? Oh, demo. Okay. So let's pull that up. Demo 1, change it to demo 2, and it should make a map like this, right? Once we refresh over here. Yeah, so now it's just building a regular, what's it, 7x7 or something like that, chunk map. Okay, so that's pretty cool. Yeah, it looks just like this. It's kind of fun. It lays out like a jigsaw and eventually gets to a map. Not as well connected as one might hope. Edges with no exits lead to a small play area, which is called at the end, but it's still a good start. We can significantly improve the resulting map in this case by reducing our chunk size constant to 3. Running it with test map 1 produces something like this. It's a much more interesting map. WC test 2 generates that. Interesting and playable map. Problem, we got such a small chunk size that really aren't all that many interesting options for adjacency. 3x3 grids really limits the amount of variability. So we can try demo 1 with a chunk size of 5. That's more like it. Okay. Taking advantage of the ability to read other map types. Rather than loading one of our XP files, let's feed in the results of the cellular automata run and use that as a seed with a large 8 chunk. Huh. This is surprisingly easy with the structure we have. In our build function, we set the chunk size to 8, generate a map with cellular automata, build map, get map, and then remove the downstairs. We have to loop over everything to remove the downstairs. Interesting. All right, let's try that. So instead of demo, instead of this load Rex map, take snapshot, we're going to do this and then start with the build patterns. Right, so let's comment this part out. I'm going to change this to a chunk size of 5, right, like they suggested in the thing. And instead, what we'll do is const chunk size 32 equals 8. Depth 0, I guess. Yay, build map. It doesn't matter what the depth is. Map equals CA get map. Okay, so this should generate a map based on the cellular automata. I'm doing a quick cargo check. We have warnings. We're definitely setting self-map. Oh, maybe because we're not using the Rex map thing. No, that's not up here. Okay. Just make sure the warning isn't something important. Yeah, okay, yeah, image loader and load Rex map are not being used. I guess we could build that with an option instead. Let's build that and see what that one looks like. And then we'll revert it. Yeah, okay, so this is a map using the waveform collapse methodology with a starting map of the cellular automata. See how it goes right to the edge there, and then it resets them. Okay. Let me look for these lines too. So I'm going to comment that out. That's interesting, but I'm going to... Where is it? Demo. Here it is. I don't know why I couldn't find it. So let's just do that, and we can leave this in as an example of how to make a map using our other map types. How to make a waveform map using other map types. Okay, so that's that. That cargo checks, right? Let's remove our dedupe. That's not in here. It's in here. 170. We don't need that. We don't need that. Right? Yep. Okay, good. Run it through Clippy. Git commit -m. And I think we're done, right, with the waveform collapse chapter. Oh no, and then we're going to do offering different build options to the game. Okay, so each one can do a different style. Yeah, so we did that with other maps as well. A test map using the rec stuff, and then a derived map using, and then we have the random builder, which I see one here using test map. Oh, and then 1 and 3, we'll just redo it with a derived map. Okay. And then clean up dead code warnings. Okay, so that's interesting that they go through that in this chapter, but not in other chapters. All right, I'm gonna save this for tomorrow. And let's see, what do we call this? Waveform map done. And then we're going to do the waveform options tomorrow. If there's time, I don't know. So advent of code tomorrow first. Right? We'll do advent of code first. Oh, there it is. That's right, I rebooted, so it refreshed the screen for me. Okay. So tomorrow we'll do advent of code version 8, or sorry, day 8. I'm not going to be awake for when it unlocks, but I'll be awake in the morning. And then if there's time, we'll get back to this and make the waveform stuff. Meanwhile, who is streaming at We Can Raid? Oh, Togglebit's there, and Raphael's there. We raided Togglebit yesterday. Let's raid Raphael today. Meanwhile, thanks very much for watching. Oh, hi, General Nova. See you. Thanks very much for watching, everybody, and I will see you tomorrow for Advent of Code and possibly more RLTK. Take care.